It is one of those really important classes at Stanford that helps you see beyond your major. It is like the bridge between two disciplines in a lot of ways. It's the bridge from computer science to biology. And it gives people from both sides the ability to come together and bring their own set of skills and then collaborate on a project.
There's a gap of knowledge between people who are very much on the computational side or more on the infrastructure side, and those people who are more on the experimental side who generate the data. I think it's very important for these people to be able to understand the needs of one another and the challenges. And this is the only way we can truly achieve new products, a great innovation.
This is an up-and-coming field. I think a lot of times cloud computing is just kind of like a buzzword that people throw around and don't really know what it is or what it can do. Creating an understanding of its potential and just explaining what it does at a very basic level is an important thing that people should learn.
I really love Stanford Data Ocean because not having gone through the traditional track of taking computer science courses, taking CS 106, I found myself having to self-learn some of the concepts such as the languages that is used like R, Python. I found myself having to navigate through that myself, but through Stanford Data Ocean, it was like having your own wiki page that tells you the basics and also very pertinent examples of what to do with that.
I think it's amazing that the platform exists. It makes learning basic bioinformatics skills and working with this type of data so much easier and so much more accessible. I certainly benefited from this as a medical student, and my schedule is very regimented and pretty busy. It was amazing that I could use it on my own time and learn at my own pace.
It seems to lower the barrier of entry into the field, at least to start. Obviously, there's a lot more I could learn about bio. There's a lot more med students could learn about CS and stats, but it kind of lowers that barrier to entry. And that, I think, is really important in terms of getting people interested.
For me personally, because I have more of a biology background, I learned a lot just about computer science and how computer science can be applied to biology. And so in particular, I learned a lot about cloud services such as Amazon, AWS, Google Cloud, etc. In doing so, I got to understand how these services can be applied to diseases such as cancer and other biological ailments.
Also learned a lot about medicine because I don't have too much of a background. So I learned a bit about precision medicine. We had a lot of really cool speakers come in, and also learned about, a lot of other considerations when dealing with, this big data on the cloud, about costs and security, etc.
It was sort of a blend of biology, statistics and math, and computer science. And what I thought was pretty interesting is that, it didn't matter sort of where you were starting from. It was taught in a way where, I was coming from more of a biology and statistics background, but in having that knowledge base, it became a lot easier to see how computer science sort of tied in to those biology and statistics principles.
This course taught me how to deal with large amounts of data, which is very important, and also how to incorporate the medical, HIPAA compliancy sort of protocols that are in place.
It was interesting to see sort of the various levels of control that a company can have that's, using bioinformatic data. And so whether they totally outsource their security to, one of the cloud providers, whether they have kind of a half and half shared responsibility for, who owns the data, what's anonymized when it gets put onto the cloud, or whether they, totally keep it in-house and then they just use services provided by a cloud provider to kind of operate it on data that they are maintaining and protecting themselves.
For me, I'm someone who worked with genomic data previously, and I would run processes and I would run them overnight only to wake up and discover that it's failed or it stopped running for some reason. And with this course, I got a really great overview of what workflows to use exactly to prevent specifically this kind of error from happening again.
Being able to learn that there are, even from the basics, very different scalability approaches, like vertical scaling, horizontal scaling, and then thinking about efficiency, cost of scaling. All of those things were not necessarily components that I had really thought about as a student researcher previously. So I thought this would be really helpful as I go forward in my career and have to think about what computational resources I purchase and what's the most optimal types of resources I use.
The thing that was most useful for the course for me was just that practical trial by fire, learning how to do these operations within these types of platforms, because you can kind of read about it and you can attend a lecture and the professor can kind of go over what these platforms can do, but you don't really get a feel for them until you actually get into the weeds and start building out your own project and figuring out, okay, how do I navigate the user interface? How do I figure out to do what I need to do in order to get the results that I need?
In this class, we were asked to actually set up a cloud computing infrastructure through either AWS or Google Cloud Service. That is a very new thing for me, even though I know that in my career I wouldn't have to do that myself, but understanding the nitty-gritty detail of it and kind of the expertise required for it, you would be able to identify talents or companies in your work that is capable of doing this, and you would be able to identify situations where you would need this kind of computational platform.
I think that this course is, a great opportunity to learn about biology and healthcare and the kind of advances and opportunities there are for someone who has a technical and CS machine learning background to apply it. Vice versa, I think it's an amazing opportunity for someone in the field of medicine and biology to learn how to leverage their domain expertise to push technology forward in the field. I really recommend anyone to take it because, it's an interesting and growing field and quite frankly, it's the future of medicine.